Okay, one more thing about conversion. We're going from here from 25 cubic centimeters to cubic meters. Now when you look up here across, these are all, you know, your basic unit is liters, meters, and grams. There's no squares, there's no cubes there. So you have to take care of that when you work your problem. You know the relationship between meters and centimeters. 1 meter is equal to how many centimeters? Right, 100. 100 centimeters. So that's meter and centimeters. In this particular problem, we want centimeters cubed. So we have to take this number and cube it. Now, whatever you do to one side, you have to do to the other side. And that's good because we want cubic meters also. Now when you do that, you get 1 cubic meter is equal to, now you have to cube 100. So that's 100 times 100 times 100, which gives you a 1 with how many zeros? 6, exactly. So this is 1 times 10 to the 6th, if I may put it in scientific notation for us, cubic centimeters. So you have to take care of the fact that you're not dealing with just centimeters and meters. You have to cube it. And I think the easiest way is just to start with the relationship you know and do what they tell you to do to it. In this case, it's cubing it. All right, now I just start the same way that I would do any of the problems. I write down what I know I have. I know I have 25.0 cubic centimeters, and now I have this handy dandy little conversion to use as I need to. I want to get rid of cubic centimeters. It goes in the denominator. I want to change to cubic meters. I'll put it in the numerator, and now 1 meter, 1 cubic meter, excuse me, is 1 times 10 to the 6th cubic centimeters. The units are going to cancel for you. This time you're dividing, so your decimal point gets moved 6 places to the left. And when I did it, I came out with 2.50, don't want to lose those sig figs, times 10 to the negative 5th. And then the unit is meters cubed. And again, like a good chemistry student, I box in my answer. Okay. Now again, to go to deciliters, that is 1/10 of a liter. I'm going to let you do that on your own. You should come out with 0.250, and that would be deciliters. Okay, again, a deciliter being 1/10 of a liter. Okay. Right. Okay. Now, using conversion factors, will be the next couple of problems that we do together here. Okay, using conversion factors while working through some problems here. Let's just read it together here. The aluminum in a package contains 75 square feet of kitchen foil, weighs approximately 12 ounces. Aluminum has a density of 2.70 grams per cubic centimeter. I'm sure you remember that. What is the approximate thickness of the foil in millimeters? Now this is a tough type problem. This is indicative of an AP chemistry problem. And just to kind of help you out with it, I brought some aluminum foil for you here. So here's your packaged aluminum foil. Now this says that an entire package of aluminum foil contains 75 square feet. We don't use square feet very often, But that's how, if you looked at a package of aluminum foil, the average one would say that it has 75 square feet in it. And it weighs approximately 12 ounces. Again, you know, I said before we wouldn't be using customary units very often, except for this chapter. And here's one example of using the customary units. Except that they tell us that the density is 2.70 grams, metric units, per cubic centimeter. And they want us to find the thickness in millimeters. So here's my piece of aluminum foil. Basically looks like a rectangle. If you take an entire sheet or an entire package of aluminum foil and spread it out, looks like a rectangle. All right. And they want to know the thickness. So in 2 dimensions, it would look like a rectangle. In 3 dimensions, that's the thickness. It would resemble what? Yeah, a box, really. It has length, it has width, and it has thickness, or it has height. And so it would look like a box, or what we would call a rectangular prism from your geometry days here. So we're given some information in customary units. We're given some information in metric units. We want to, they gave us a little bit of information here. Again, you won't have to memorize conversions between customary units and metric units. If you need the information, they'll give it to you in a problem, or you'll have another sheet that has the information in there for you. So let's start off. Just wanted to give you a little information as to what you were dealing with here. We have a couple different ways, again, that you can approach this problem. I'm sure there's several different methods. As long as you communicate how you did it, you're going to be good to go.